Yeah, as Chris mentioned, I'm going to walk through building a Linux packet node, right? And the subtitle I think is pretty apt. Apropos, it's how to hack together a 1200 baud Swiss Army knife from antiquated software, and I can tell you it's definitely antiquated software. I've been dealing with some issues from this stuff, and just had to patch something last night to get things working. But it's been an interesting journey, and hopefully you can all learn from what I've walked through here. So let's take a look. Let's see here. So this is how it started. This is a message that I sent to Hugo's packet node BBS back on November 6th, and I'm glad he took a screenshot of this. I had learned about packet really through the ORCA. There was an agenda topic like this, and then there was a workshop, and so that's how I learned about packet. And until that point, I didn't know there was even like a world out there. If you're tuning around the bands and you hear digital noise, it's just digital noise. You don't know what's happening until you get it all set up, and you can see what's going on. And those ORCA agenda items really opened my mind to it. So I thought I would give it a try, and here I made it. I connected my TS2000 and connected to Hugo's node, left him a message, and told him, I'm thinking about getting a Pi set up, with an old D700 that I had. And you can see I was so green at the time, I didn't even know how to properly end a message. That / exit shouldn't be there. That's me trying to figure out how do you send a message, right? So that's how it started back in November. And then this is what it's looking like today. The node has grown quite a bit from the early days. Yeah, there's like 3 radios there, a couple signal links, and a lot going on. I'll go through all that. So why a packet node? For me, it started originally, like I said, with curiosity after those agenda items. And I realized I had some old gear lying around. I did need a new project, but the more I kind of researched and got into this, it seemed that these packet nodes are the kind of foundation of what many groups are using for their emergency communication data infrastructure, right? Their data infrastructure. And here you can see a number of points on the map. Each of these dots is a packet node that's out there. You can see there's quite a good covering around the Bay Area and Sacramento all the way over to Tahoe. There's a number of use cases that you get by being able to tap into this, right? So for communication during an emergency, you can use packet nodes to transfer messages that support the ICS forms that everyone gets trained on. You can also post or host information services on these nodes. They can serve as not only a bulletin board system, but as a WinLink RMS, right? A gateway to get your WinLink messages out. You can use them for APRS digipeating. All these things could help during emergency communication scenarios. And what you also get with them is the ability, to extend beyond the line of sight that you get with VHF, UHF, right? You can link these nodes together. You can pass messages through them, either through digipeating or using Netrom connections, which is like routing. And you can also have HF links that allow for packet message transfer over long distances, right? I was watching some old videos, and this stuff was starting to grow before the internet, right? And I was watching some old YouTube videos, and these guys were just fascinated about how they were able to talk to someone in California, bouncing things off like something or a satellite or some uplink or whatever, and it was just fascinating. Like before the internet, there was like a network that was forming of these across the entire country and the globe. But then the internet took over. But they still have some value, and we'll take a look at that. Yes, and you can have fun too. There's chat you can do. When there's not an emergency, what do? Right? You have fun. You experiment. You tinker. There's chat rooms. There's Sunday night packet net, which I'm sure we'd encourage everyone to come and join us on. And yes, there's even games you could host on these. So we've been learning a lot from Santa Clara County about how they've set up their EmComm infrastructure and what this diagram comes from one of their presentations. And what you see here with the blue box that says Site 1, that is basically a packet node. It's a little bit more than that. It's a when you dive into the details, there's a computer of some sort. Could be a Raspberry Pi, but it could be bigger. That has packet services on it, but also other internet services. But the idea is that their EmComm infrastructure is based on having a number of these nodes around the region networking to each other, and also allowing for various modes of access. You can see over VHF, UHF, Wi-Fi, etc. And we're going to be looking at something similar, possibly for Oakland. So I've been looking at this node that I've been building almost as a proof of concept or a prototype, just trying to figure out, what works, learning some lessons so that we can apply it when we go in and come up with our formal plan. Any questions so far? Is it coming through okay?
Great.
Cool. So why Linux, right? The title of this presentation is building a Linux packet node. Well, Linux has native operating system support of the AX25 packet protocol.
I'm having trouble hearing you.
Okay, I guess we've got another, I guess Siri, the person whose name starts with S is listening. So what's great about this is it allows for extensive customization, right? Linux is a platform to build things, essentially. So if you think about computer operating system, you've got the hardware layer. This is where you have your serial ports, your Ethernet cards. Then on top of that, you have the operating system, the kernel, let's say, is a part of that. There's a lot of detail here, but the thing to focus on are these orange boxes. If you look at the orange one on the right, within the core kernel, you have TCP/IP, the protocol we use for networking communications every day. Well, just as that's baked into the kernel, you've got the three orange boxes to the left, AX25, net/ROM, and ROS. They are all packet networking protocols. I mean, they're networking protocols, but they're, in this case, used for packet radio. So just as you could program and build and access a socket or connection over TCP/IP, you can do that with AX25. Now, what's interesting is it is antiquated software in a way. It was started a long time ago. There's been a number of folks that have kept things alive for a period of years, and then it dies off, and then somebody else picks it up. What's really great is that this just came out in December. The Amateur Radio Digital Communications Group, ARDC, they're the ones that own these IP addresses, the AMPRNet, and they've sold them off, a block of them off to get a whole bunch of money that they're issuing as grants. We may be able to take advantage of that money this year, hopefully. They have issued a grant for $200,000 here to basically fix a Linux kernel AX25 implementation. There's some group, Deutscher Amateur Radio Club, that apparently is going to do that. So this is, I'm optimistic. I'm hopeful that some good comes out of this, and maybe some of the bugs I'm dealing with are fixed soon. This shows that this is still alive. There's people using it, and it's getting some more investment. Now, there's lots of ways to get a packet node up. In some of the previous ORCA sessions, you saw Chris and Ryan and others talking about the Cantronics. And so you've got this idea of, well, you could go get an appliance, or you could, build something yourself. And this just shows some comparisons. Costs could be comparable. The setup is a big thing. It's much easier just to get up and running with an appliance. If you're going to do something where you're using a Raspberry Pi or other type of computer with Linux, and it requires some system administration experience, there's definitely a level of complexity there. But I should make a note: the path that I went down here is probably the most complicated path, because I was trying to basically install everything bit by bit. But I think there's a follow-up topic we could have. There are even for Linux, there's kind of a node in a box software solution like JNOS or BPQ. if you're familiar with them. That's one thing that you install. It still has some complexity in the configuration, but it actually may be an even faster path than the path I went down, which is trying to, like, those things represent a suite, and I've basically been working to install everything piece by piece. So keep that in mind. If this looks complex, there may even be some simpler options there. But the positives, right? Like, you lose the LED lights. You don't have the status light showing you've got mail waiting on an appliance, but you do get a lot of ability to customize and extend this. But security is another factor here that you have to focus on, right? Especially if this is on AmperNet and it's opened up if you're opening up access beyond just the RF, through your firewall, you definitely need to know how to lock this down. Otherwise, there's lots of attack vectors that could be compromised. Any questions? So it took me a while to understand, like, I wanted to build a node and I didn't know, well, where do I start? Like, what are the pieces? Like, I've got a radio. Do I need a TNC? Do I need a Cantronics? If I've got a D700, or I saw some videos and they had people using sound cards. It took me a while to understand this, but I think I've kind of distilled it down. Hopefully these slides aren't too complex. I just want to focus on the high level here. But it seems like there's like 6 flavors or 6 combinations of parts that could get you a functioning node. And by node, I'm talking about something that is up 24 hours, right? 24/7. So if you have a radio like a TM-D710, that's got a built-in TNC. And if you were to plug that in, turn that on, that could function as a node. It'll sit there. You could potentially do digipeating. You could allow people to connect to it and leave you messages. It has some features in there, but that feature set is limited. But this is a valid option, probably the simplest one, and the D710 has a great built-in TNC. If you have a radio that doesn't have a built-in TNC, then you could go and get an appliance like the Cantronics. And what you're doing there is you're allowing that to function as a modem, right? You're allowing the radio's RF audio to be converted to digital data. In this case, the end of the chain here is that Cantronics, so all the features and functionalities there baked in as part of that TNC. There is bidirectional communication here. I'm just showing the arrows as just the receive path, just to help understand, like, how do we pull digital data out of the air and then do something with it, but it is bidirectional in the end. Another option that you can do is you can say, well, I want more. Let's say you want more features than what that internal TNC offers. You want to host WinLink RMS, or you want some type of chat system, or maybe a different BBS than what's built in with some more features. What you can do is put that TNC in KISS mode, where it then just acts like a modem. It converts the RF audio into digital data and it just makes that accessible. It passes it on to the computer, that's where the AX25 protocol stack picks it up, and then the applications can work with that data. So that is a third option here, where if you want some more control, more features than what you get from that built-in TNC. You can also do that with the Cantronics if you wanted. You could put it into KISS mode and it'll just pass the data on to your computer. But there are other options too. You can use a software TNC on the computer. In this case, let's say it's a Linux on a Raspberry Pi with the Direwolf software. In fact, there's performance benchmarking that's been done, and the Direwolf software seems to be really like a top performer and can outperform a number of the hardware TNC implementations. So there's radios like the IC705 that have a built-in sound card. This is the simplest setup. You just plug that USB cable into your computer and connect Direwolf to it, and you've got a TNC and you can run all sorts of apps on it. Another option is to use, if you don't have an internal sound card, you can use an external sound card, in this case, like a signaling. So same concept as what I was just talking about, it's just that it's external. So you can also mix it up if you've got a dual band radio, right? You can have, two basically data streams that end up going into your computer, which end up being two ports, two pathways for communication. And those pathways could be on different frequencies or even different bands. And you can mix it up even more, right? You need a computer with lots of USB ports, but this is showing, you can have two dual band radios, and you can have 4 ports or 4 data streams going into a little Raspberry Pi, which is kind of what I did. So, let's go take a look at the actual node that I built.
Jim?
Actually, before I do that, yeah, any questions?
Yeah, we had one question in the chat asking about what a TNC is. I put some basic answers in there, but do you want to say a little more about what a TNC really does?
Yeah, I mean, I believe it's terminal node controller, but it's basically a network node that, as I mentioned, it has one function, which is to act as a modem, right? Where it takes these the blue kind of wavy lines here. It's probably a better way of looking at it. It takes the RF audio, right? And just like if you used a modem in the early days of the internet, right, where you did dial-up, it's kind of doing that same thing, right? Converting it to digital data, but then it also has some protocols encoded in on the firmware. It has some services encoded in on the firmware, so it can be a place that it can do things. It can pass messages if you set it up that way. It can be an end destination that has a little message board or BBS sitting there, a personal message system where people can connect to and leave you messages. It can, it has a number of features. We'll take a look at some of those in a little bit, but hopefully that, yeah. By the way, I'm totally blind. If there's any chat questions or funny looks on people's faces, let me know because I can't see anything.
Yeah, I'll let you know if there are raised hands or questions or anything. Thank you.
So let's take a closer look at my node. This is the rough location of where I'm at. It's about 900 feet up in the foothills. It's not all the way up at the skyline, but it does have a little bit of elevation. What's interesting about this location is Chris is roughly over this direction, and Hugo is down there. Now, those two both like to play with packet, but unfortunately, they found out they've got this big hill of Piedmont in the way, and so they can't play with each other directly, right? So wouldn't it be nice if I can hear both of them, maybe I could act as an intermediary and connect these long lost friends, and we were actually able to do that. So when I set up this my first experiment, I'm just like, well, I need another antenna. I'll just borrow my 6-meter mast and coax and just put this 2-meter, 70-centimeter J-pole up. And then I bought a Raspberry Pi, but I had a signal link sitting around, and I had an old TM-D700, which was my first mobile radio, and I ended up basically repurposing that. So started with those. I had to get a cable for that data port on my D700 that runs to the signal link, because I'm trying to use, so for this D700, I was trying to use both band A and band B, and one band is basically on the internal TNC, and the other is on whatever the PTT is set to, and that's what this sound card cable is tapping into. This one here, this other data port here, or I guess it's a COM port, that is connected to the internal TNC. So this was the very first node that I set up, just put it on the side of my desk, and I found a way. There's this great product, it's called USB Buddy. It's this USB-C to power pole adapter, and that allowed me to plug it into my rig runner, which I've been using for power distribution, and that means that everything that I'm using for my base, like the failover you get from this Epic Power Gate, the backup battery, that was all applied to the node. So now this radio and the Pi and the signal link is powered from the Pi over USB. It's now all on battery backup as well. And that's important when you're hosting these services, especially for EmComm, right? And this is a diagram of those connections. Thank you, Hugo, for drawing this beautiful work of art. I don't think we have time to dwell on a lot of this, but you can see some of the cabling, and if anybody's going to go venture down this path, I'm sure a number of us can help you figure out what are the right cables for your radio. If it's one that I'm sure a number of the popular radios we've all been working with, but we can help you out with the other ones as well. So there are two interfaces on this version. I had, as I mentioned, band A and band B of the D700, and I chose two frequencies. One for 505 there's a band plan for packet, and one for 505 is designated for keyboard-to-keyboard chat, personal mailbox, stuff like that, Netrom, digipeters, and there's a Sunday night packet net. There's another frequency, 144.910, which is kind of designated as an EmComm frequency, but it's okay to use it if there's no emergency. What's also interesting, if you remember our tale of two packeteers here, Hugo spends all his time parked on 14505, and Chris spends all his time on 144.910. And what's interesting about that, I'm sure Chris could tell you more, but it seems like Hugo got Chris to get parked on 144.910 and then abandoned him. And so wouldn't it be nice to bring those guys back together, which is what I was able to do here. Anything you want to add to that, Chris or Hugo? Hopefully I'm not embarrassing you guys.
No, that's about right. But no, it's good to awesome to be able to connect again and jump those frequencies and connect the activities going on the two different frequencies.
Yeah,
I plead the fifth.
So those are the ports, right? Okay, that's just like pathways to access stuff. So what are you accessing? Well, those are the services. And on this first generation, there was the main node, which I gave the alias of MONTC for Montclair. That was on K2YE4 initially, and that was running this Linux node software, and that was accessible from both frequencies. This is the thing you would connect to from your computer, hooked up to your radio, and you would say C, MONTC, and I'll show you what it looks like, but you basically land there with a prompt. You can run a bunch of commands and connect to other nodes and do stuff. But I also was running WinLink RMS on K2YE10. I had that available on both frequencies. And then there was a digipeater service that was available on both of these frequencies as well. Now, on the software side, there's, it did take me a while to figure out how this comes together, but I'm going to just briefly walk through the different levels of software that are installed, and this is in the order that you would install them. So you start here with the Raspberry Pi operating system as the base. By the way, you could do this with it doesn't have to be Raspberry Pi, you can do it with any flavor of Linux. Now, once you've got the operating system installed, then you need to, depending on how you're connecting to the radio, if it's, or the TNC, right? You may need to deal with, if you're dealing with sound cards and you want to use Direwolf as your software TNC, then you need Direwolf, but you also need some sound tools, also utilities. Being able to mix the sound card levels is very important to get them not, loud enough that they'll trigger PTT, but not too loud that they're distorted. So there's a lot that has to happen here, right? If you aren't using a sound card, you may want to have some utilities like EmComm to just test the serial connections and be able to log into your external TNC so that you can, change some settings or whatnot. And there's also scripts that can be used to kind of set a bunch of parameters automatically at boot. So once you've got these connections squared away, that's when you get into the actual protocol stack installation. So for AX25, there's a number of packages. There's the core library, AX25 tools, AX25 apps, which bring a number of the services that are running and the tools that you run, like the commands that you run. Like if you wanted to listen and monitor all the AX25 traffic, you would use the listen command shown here. If you wanted to connect to a node, like you can do that right from a Linux shell. You can just connect to another node and you would use the call command. Or beaconing is also another command here. Now, when you install these, what's interesting is Netrom is also another protocol, but it comes with AX25 tools, the Netrom daemon and some other commands to manage Netrom routes and save them are all a part of that package as well. And then once you've got all that done, then on top of that, now we get into the user applications or services that are running. That's where you can install the node software, the RMS software, maybe a packet client like LinPack. And then I threw in there some games as well. I was inspired to go down the Linux path when I saw a YouTube video and I saw somebody had installed Zork. Like you could connect to their packet node and play Zork. And I thought that was so cool. So there's this emulator called Frotz, which you can install. You can download Zork. It's license free and it's running on my node. If you want to play Zork and have some nostalgia, you can connect to it and type Zork in. And you'll be looking for that jeweled egg. I think this is all I'm going to say about this now, but we could do a workshop on this stuff if people are interested, where we go through all these steps. I have a bunch of slides where I walk through the steps on doing each of these things. But any questions before I move forward to Gen 2?
I don't see any questions here.
Okay.
I do have another question. Well, it's a question. It's not technical, but it will be very interesting to know if these slides can be available to us.
Yeah, we'll find a way to get this hosted somewhere for sure. Definitely.
Okay, thanks.
We'll get these slides up on the website, no problem. These are amazing slides, by the way.
Yeah, they are. Yes.
Yeah, I was trying to. Honestly, I feel like I've pieced together a lot of scraps, and there are some good guides out there. I would say David Ranch has this really, really excellent guide at trinityos.com. It's completely thorough and extremely thorough. I mean, it covers everything, but it is very advanced. There isn't a happy path or a fast path. I mean, it's everything, but it's an incredible resource. So you definitely should check that out. But we'll get this posted as well. I was hoping this could serve as a good onboarding guide, right? Kind of get the mental model and understand things at a high level first. And then when you have some hiccups, I'm sure he covers a whole bunch of edge cases that I don't cover.
Jim, we have a hand up from Mike, EWP.
Yeah, what's up?
Hi, Jim. Mike, KP9EWP. Question. When you were researching all this, did you come across, are they still using JNOS or TNOS?
Yes.
Or packet?
They are, in fact. They're the Santa Clara County's EmComm infrastructure is all based on JNOS.
Okay.
There's a lot. What I'm seeing, the predominant nodes out there are JNOS or BPQ. It's Bravo Papa Quebec, I think. Okay. BPQ.
I believe so.
So, yeah, and I tell you, like I looked at that and but I wanted. I just felt like I wanted to really understand what was underneath the hood, right? But I think I'm going to have to do a follow-up maybe in another month or so and let you know what did I ultimately decide, because I'm tempted to go and just install BPQ or JNOS. I'm hoping that maybe it doesn't have some of the bugs I'm dealing with, but yeah, those are very popular, and I think those are definitely a wise path to take to get a packet node up.
Okay, yeah, in the early 90s, I remember having a packet station, and I started with JNOS, and then there was another flavor that came out called TNOS, and it seemed like it did most of the stuff you have here, like the AX25, Netrom, all that stuff. And like you said, it was like all built in. So like if you really wanted to learn it, I guess you go down the path you're going through here to get an understanding of everything that's under the hood. So, but I was just curious.
Yeah.
Yeah.
My path was really swayed by Zork, to be honest.
Okay.
I saw how to, to get Zork up and running, you kind of need to do it this way. Maybe there's a way, I'm sure there's a way with JNOS to also link to another app, but this is just a path that I took. But also I should note, like JNOS is very complex too. Like there's different parts of it, like especially BBS configuration and routing and whatnot. It is a whole, basically what JNOS is if you see the bottom, well, let's see, where you see AX25 Netrom all the way up, if that, JNOS is basically a big box that's right on top of, Direwolf and serial tools. It packages everything together.
Yes.
And it makes sure that these things work together, which is beautiful, but it still requires, I guess it's probably very similar to what you used before.
Yeah.
Just letting other people know maybe that aren't familiar with it. It still requires, has a little bit of a learning curve, but it may be easier to get it up and running than this path.
Right. Okay. Thank you.
Jim, there are a few questions I got about some of the acronyms. I'm not sure yet which ones exactly, but like JNOS, TNOS, BPQ, they're all sort of ready to go Linux software packages that sort of do all or most of this for you. Is that right?
Yeah. I am not entirely sure what the first letter represents, but I believe it's like network operating system. The idea is you can, when you go into the admin console, it's just a place where you've got the ability to go and configure all this stuff. You can configure the AX25 protocol, which is the lower level link protocol. The Netrom, just think of that as a routing protocol on top of that. You need to make sure those things are configured right, that they're tied up to your physical connections, which is the layer below, like which COM ports kind of, right, or devices that are registered with Linux. So it's, and then it has all the features, right, whether it's, the node shell, the RMS, the BBS, chat service.
Yeah.
A lot of those features are all packaged in I don't hear, I hear JNOS and BPQ. So I would say there may be some other flavors, but it seems like what is popular are those two.
Sounds good. If there are folks who have other questions about terminology or acronyms, you can ask now or, put those questions in the chat and we can try to answer some of them there as Jim goes along.
Okay. So this is kind of funny. This, with this first generation, I got it out there. I think Hugo found it and logged in, and then he sent me this. He was loving, this is what you see when you logged in, right? There's a little bit of ASCII art, and I had color enabled on this Linux node. I did get my hand politely, not slapped. I don't think it was slapped, but I did get a note from someone that, hey, people that are, logging into your node, they don't have a color enabled client. It just looks like a bunch of gibberish, right? But I know that Hugo and I certainly appreciated the color, and I would love to see more color out there. It is the year 2022. Wait, I don't even know what year it is anymore. But anyways, I find it interesting that there isn't a lot of color in use when it could easily be just used. So let's talk about the second generation. So as I started to read more and more about how these packet nodes were used for EmComm, that's when I realized, oh, okay, some of these nodes they have BBSs and they're using a 220 radio for a back channel between the different BBSs. And because that band is hardly used, there's not a lot of users. So it allows for a lot of these BBSs just to have this constant dialogue back and forth. Do you have any mail waiting? Do you have any mail waiting? Oh, yes, I have some for you. Here you go. And they're passing messages between each other. So it seems like that, at least the way folks have deployed it, you don't have to use 220 for that. You could use other frequencies, other bands, but it's an unused band, and they were taking advantage of it. I know Santa Clara is using that. So I got a 220 antenna up here, and I wanted to open up to more frequencies, and so I added another 2 meter, 70 centimeter J pole. And yes, I got some unhappy looks from my wife. These things are basically all around the deck railing of the deck on the back of our house. Yeah, so then I had to run some additional coax. The first time I just piggybacked on my 6 meter line. That was the blue circle there. But I had to run another line for the second 2 meter, 70 centimeter antenna, and then another one for the 220. And I'm definitely running out of room. I'm probably also not doing things the smart way. I need to think about maybe a duplexer. I don't think I have time to go into it now, but if anybody has thoughts on antenna strategy for something like this, Mike, the more I thought about this is probably like a repeater in a way. And there's things I just don't know, and I might not be doing things in a smart way. So maybe we can follow up on that. But I gotta figure out a better plan here. And then the hardware, let's take a look at this. I've got it all mounted on a rack. The Raspberry Pi is a little guy that's inside there. He's basically hidden underneath a bunch of stuff. I got this 8 gigabyte, 128 gigabyte SD card version. I'm barely utilizing those resources. There's tons of free memory and tons of free space. I just wasn't sure what I was going to need. I don't think you need a lot for this type of thing, but I'm not using a graphical user interface, right? So this is kind of all just command line installation of the OS. Maybe if you're using a GUI, you need a little bit more, but doesn't require a lot of resources. Now, I mentioned the Raspberry Pi that I got had 4 USB ports, right? And that's also one of the reasons why I bought that one, because I wanted to be able to plug as many things into it as I could. But I have, with the second generation, I have 5 ports. So I needed to find a way to get more than 4. And this actually has been working out really great. This is this 4-port USB to, it's a 4 ports, I would say, serial to USB hub. And you can see I've got the D700 internal TNC on this cable, and then the D710 internal TNC on that cable. And they got nice little status lights, and I've got room for some expansion. And then these are the 3 radios. I ended up picking a used D710 on eBay, and then another used BCM, a Bridgecom 220 radio from eBay as well. By the way, these 220 radios seem to be very scarce. A lot of them are being discontinued. If you're interested in having that capability, you might want to look now to find one. I did have to do a little bit of homebrewing of the cable for that 220. Save that for another day. There's 3 signal links that are in there. And this is just showing, which ports are on which, right? But basically, everything's labeled as you see in this photo. And I also just put things on their own power supply. I wanted it, it was getting out of hand on my desk, so I wanted to just give this thing a nice dedicated power supply and backup battery just for the node itself. And then this is the icing on the cake, I guess. There's this. This is a nice little 7-inch screen. It's a touch screen. I don't use the touch features, but just put this on top so that I could monitor the packet traffic across the ports. And it works well, but it was the little USB power supply it came with was horrible. It was when I set this thing all up and I did the cutover. I turned on my HF radio and I had S9 noise on 80 meters, and I had before that S1. I'm like, oh my God, tell me my node is causing this. Luckily, I was able to trace it down to just the little a power supply that the USB power cable plugged into. It was just some cheap thing, totally unshielded, I guess. And once I got rid of that and put it on that USB buddy and it connected into my Parapole rig runner distribution, everything, it completely went away, the noise. All right, so maybe before we get into that, questions on the hardware.
Jim, I was curious why all the signal links instead of using simpler just audio interfaces, USB audio interfaces, and sound and software modems.
Yeah, great question. Well, so when I did my prototype, the first version of this, I had a signal link on hand, and so I used it. And what I actually stumbled into with that is being able to trigger the transmit. It's going to be different for each radio. What's nice about the signal link is they have a built-in Vox or voice-activated transmit circuit, and so it just was convenient, a little bit of familiarity, right? That I had done it already with that. There are different options you could take, but there's also some things to David Ranch's website, trinityos.com. Go there or look into, he's got 2 pages, one on a Raspberry Pi setup, one on a CentOS build. And on one of them, he goes, maybe even on both those links, he goes in depth on comparing different audio cards. He actually recommends something even different than the signal link. But I've found the signal links to be working quite fine. The one thing about the signal links is they do have a very audible, I don't know if it's a relay or a switch or something when PTT activates, like you hear a click, click, right? And I'm waiting for the day when all 3 of these are going at once to see what that sounds like. But you know, that's a moving part. Makes me think, how's that going to hold up over time? I don't know. Maybe it's built well, but
is that
yeah.
possibly a plus to be able to hear when it's transmitting?
Yeah, probably. Okay. Right, because you gotta, you know, that's the other thing, right? Like you got to make sure this thing doesn't run away from you and get stuck transmitting in noise or in a loop or setting operating system sounds out there. So yeah, that probably could be viewed as a plus.
The LED light comes on, I think, also when it transmits.
Yeah.
Not always looking at the LEDs though, and if you hear the click, click, click going on, then you're like, oh, what's going on?
Yep.
Cool.
Okay.
Mike, did you have another question, or is your hand still up from the previous question?
Yes, I did.
Okay, go ahead, Mike.
Jim, what flavor of Linux are you using on that Raspberry Pi?
It is, wow, what's the name of the latest, whatever the latest distribution is.
Okay, so it's just what came with what comes with.
Like, is it Buster or something? I forget the name, but it is,
it's a Debian, what is it?
Debian,
Debian flavor, okay.
That's actually another interesting point. There are many paths to this, right? There is another path, which is there's somebody that has created a ham Linux build. I forget what it's called, but I can find the link later, or I'm sure you can find it if you Google it. But there is a build, like you could just get an image, put it on your SD card, put that into the Raspberry Pi, boot it up, and you're going to have all this stuff installed. Right. Again, I wanted to build everything. I like building things, so. But that is another interesting path.
His first name, I think, is Jason. Yeah, the guy he has a lot of YouTube videos on setting this up.
Right. So
I heard that Raspberry Pi just came out with a 64-bit OS like this week.
Yeah, I think some of these things have, like this Raspberry Pi 4, I think there's 64-bit capabilities. I don't know. It's an area that seems like you got to turn it on a certain way, and then not everything's taking advantage of it. So maybe that's
I don't know. I don't know the trade-offs. I have heard that they're really hard to get right now. They're really impacted by the chip shortage and the supply chain issues.
Yeah, I noticed the model that I bought was not available on Amazon anymore, but I'm sure it'll come
Anybody's
back.
really desperate for a Raspberry Pi, I have some older ones that you might be able to borrow if you want.
So let's see if I can get into a little bit more of the demos, but just to wrap up the interfaces here. So you can see I have 5 now. There's the original 2 frequencies that I had this on, and then what I added was 145630, which is another EmComm frequency. And then the last 2 rows here are showing BBS frequencies, right? 14509 is a user access channel for BBSs in the area, and 2236 is for the BBS backhaul forwarding. Software is basically the same. There's some differences. I'm looking at adding a BBS and whatnot. But let's go take a look here. I think this is going to play sound for me, but I don't think it's going to come through. But this is just showing, okay, so what does this node look like? And, you know, this is just showing if you had, you can't hear that sound, right, Chris?
No, I'm not hearing anything.
Okay, that's fine. So basically what this is showing is from your client, like let's say it's PuTTY or it could be anything, you type connect to Montclair, this is what you would see when you log into it, and you'll hear a bunch of, you know, buzzing noises from as all the packets are being exchanged. Question mark brings up a list of commands. Some of those commands are default ones, some of them are custom ones, like you can see I added in the Zork and other things. This typing int shows a list of the interfaces, right? So you can kind of get a reference of, okay, what frequencies is this node listening on? And then jheard here brings up this just heard list, which is, you know, in the last few minutes or maybe even an hour or whatever, like what stations have we heard? And you can see a number of these call signs, and you can see what device or interface they're on. There's other commands you can do. If you type in nodes asterisk, you can just type nodes for a short form. But if you type nodes asterisk, you end up with a kind of longer list with columns that shows, you know, what is that node's alias and call sign, the quality of that link, what interface is it on, and who is the neighbor that's given you access to that. So the neighbor column is a bunch of, those are the ones that I am able to talk to directly. Okay, so there's some routing that's been detected, and it allows me to access nodes through another hop that I can't see or access directly. Now here I'm showing an example of making a connection. You can type in C AX0 Oak. That's saying connect to the Oak station over interface AX0, and this is Hugo's station on and he's out there listening on 14505. So here's an example of, you know, once you've connected, right, you can type in, a lot of this is the stuff that was demoed in the previous ORCA sessions, right, on Packet, right? You can connect to the BBS, list the messages, send a message, all that kind of stuff. But I won't go deep into that since we did cover that before, but this is just giving you a little bit of a sense of what it's like connecting to the node. Now, stuff we covered, let's take a look at, so you won't hear Hugo's voice here if we do this, but if I jump ahead to about here, this is Hugo basically giving a demonstration on how he would go and connect to Chris's node using one of the digipeters that I have set up. And you can see the list of digipeters over here. So Hugo's on 14505, Chris is on 14491. And what he's going to do is he's going to go type connect to, I think it's Burke MB. And then he's going to say via, which is to say, I want to use a bunch of digipeaters. Here's the digipeaters. You can build out a number of these as a path. And he's going to say K2YE7 because that's the one that transmits out on 14491, which Chris is listening on. So you could string out other digipeaters, but he typed this and right away he's connected. So behind the scenes, what has happened is, if we look at the next station here, what's happening here is, all right, the next slide here, here's Hugo again, who just issued this command, and my node is hearing that, and it's basically picking it up and it's transmitting it out on a different frequency via the K2YE7 digipeater. And in this case, there's no, and this log file here actually is just showing what am I seeing while Hugo's doing that. You'll see the asterisks here are showing the digipeater traffic. This is where we heard it from a digipeater, but this second log that you see here is the digipeater log. And every time you see a line show up here, that just shows that one of these digipeaters is basically firing and retransmitting.
Jim, does he not have to indicate which digipeater he wants to go in on? He didn't put K2YE-6 anywhere in that command.
Right. It's really, and this is yeah. In some ways it seems counterintuitive. It was for me initially, and I'm thinking that's
it's getting real quiet. That's for sure.
What was that? Anyways, the mental model, the way this works is you need to specify the digipeater for the frequency that the node is on that you want to connect to. Like basically since this node is listening on all those frequencies, honestly, I'm not really sure why it is that way. Maybe they could have coded it differently, but you have to use the one that outputs on the target node frequency.
Right. Okay.
Yeah. This is another example as we get close to wrapping up here. Probably not going to be able to read a lot here. I'll let it scroll while I talk to it. But I happened to look at the logs one day. I heard a bunch of clicking on my signal link, and I saw what was happening here is this one station, KJ6M, had connected to Montclair using this command, C Montclair. Then once he was on Montclair, he then connected to another station, and actually this is actually what he would have typed was CAX1 KJ6M12 to specify going out over that port. But he made a connection out to a different frequency, and this is using the connected protocol that you get when you make connections over AX25. The digipeaters that we just showed you previously, right? This is kind of an unconnected protocol. The digipeater is just going to broadcast those packets that it's told to broadcast, but there's no waiting for acknowledgement to just find out if anything was heard or not. So what inevitably happens is with digipeating, depending on the situation, it can be a lot more inefficient, actually, than doing things this way. Because here you have packets that are sent, and then we check for acknowledgement. We make sure did you have number 1, number 2, number 3? If not, then we go and resend the one you didn't get, right? And so that's actually why this is essentially more efficient and reliable way of making connections. So I think we're at the top of the hour. There's some other things here. This is just showing, there is K2YE10 now. That's an RMS that's up on three frequencies now. I'll skip over the demo of that. As far as like what's next, there's a couple things I've got in mind. I've got a Netrom connection issue. I'm going to look at getting a 9600 baud port set up to see if just experiment with that. And then I got to get into this BBS configuration. There's a lot of options there. I want to make sure I get the BBS configured and get forwarding working. And then the kind of grand plan here, the idea is to get this node on AMPRNet, which requires some things here to figure out how to get this IP encapsulation to pass through so that it can talk to all the other amateur radio nodes that are on the AMPR network. And then the last bit here, the idea is to get this also on the mesh, right? I've got my mesh node that's hosting a local network, and I'm basically going to use that network switch that you saw in the photo of the node to, do some networking, basically get it onto the VLAN for the mesh as well, so that the node, the BBS, and the RMS can all be accessed via the mesh. And that's the seed of, I think, an EmComm infrastructure idea that I have, how, if we can get these things also on the mesh, then you can access the messages on that BBS no matter where you are. If you have some way of getting onto the mesh, it doesn't have to be a line of sight to my mesh node. You can get on any mesh node, and theoretically, you would be able to route over the mesh network to the BBS. So yeah, that's what's next for me. And then, maybe we could do some follow-ups. I've got some ideas here. If there's interest, we could do a workshop, a deep dive on AX25, or we could take a closer look at BPQ and JNOS, which is what I'll be doing as well. Any other questions or comments?
Hi, this is Thanasi, KM6GNX. I just have a comment. Basically, what you have set up here, which is great, is infrastructure, right? It's not something that the rest of us necessarily have to set up in order to use packet mods, correct? So
yeah, that's correct.
Yeah. So
like if you want to connect to my node, so I think there's a recording of the original packet work sessions that you did, that we did here, right? But you basically just need, how would you say, you need to have some type of TNC on your side, right? So you need a way, if you want to communicate out, you have to make sure that you've got a modem that can translate your commands into audio frequency and get it out over the air. So you need some type of TNC. It could be it's an internal TNC in a radio you have, or it could be buying a KPC3 plus Cantronics, right, which I think is very popular. And then you can, there's software routes as well, right? Like you could go with a Raspberry Pi and like you could use what I showed here to create your own personal access node, right? But basically, if you want to get on the network and access a node, you're basically going to become a node, even if just briefly, right? You will have a call sign identifying your traffic, and people will be able to connect to you. But if you're just doing it for an hour or whatever, then you can turn it off. You don't have to worry about leaving it up all the time. And it doesn't need to be as complex. So there's definitely a simpler path if you just want to access these services, but you do need some way of doing the TNC function with your radio, whether it's an external TNC or one that's already built in. I don't know, Chris or Brian or Hugo, if you want to add to that.
Just say that there are lots of options there, depending on sort of, how much you want to spend and how technical you want to get with it. If you can get one of the Kenwood TMD 710s, or like one of these, this handheld actually has a TNC built in. I think some of the new Anytones have TNCs built in, so you can figure out how to connect to those and just use, connect your computer to it and use that as your TNC and radio to connect to Jim's node or any of the other nodes, right? Or you can, I believe there are ways to do it just with a sound card and some software on the computer to act as the modem and the TNC as well. Or like Jim said, and as we had in previous presentations, getting one of the Cantronics units makes it simpler.
Right.
Hugo, any other thoughts on that, or Ryan?
No, I don't. I just want to comment on. I started off with the Cantronics. I moved on to the Pi, and that proved uh, challenging for me personally, and to maintain it and keep it running. It became, at first I followed along with Jim's help, and Jim held my hand quite a bit. But as the complexity increased, I went back to the Cantronic. And so
It was also when you started getting attacked by the Russians.
that's right. I was getting about 8 to 10 attacks in which every day, and I started getting a little worried because that wasn't happening before. So I closed the ports, and I said, the heck with this, I'm going back to Cantronics. So it's more
actually
yeah.
we should clarify that too, right? What Hugo did is he opened up a port so that I could access his note, right, over SSH, and it was very well locked down. Any open port on the internet is going to get attacked. It just happens. It's happening to all of us right now. People are scanning our internet routers. We just don't see it. But when you open a port, and your ISP send you a nice report, a little bit of a scary report, but it sent him a nice report showing that there were attempted access from known malicious IPs. But yeah, so I just wanted to, just alleviate some fear. You don't have to open up a port to do one of these things. That was just something unique that Hugo and I set up.
Well, one last thing I want to mention is, kudos to you, Jim, for setting this up. The ability to link these frequencies on VHF and across 2 bands is a huge service to the whole Bay Area. There are places, there are many packet stations that cannot reach one another, and because of your the way you set up your distributors. And now some of the folks, and I know there's Rick KF60OZ is here. Welcome, Rick, from the Red Cross. And
hey,
we
Rick,
often,
you made it.
and we often have issues sometimes. I can't reach stations in Half Moon Bay or some of the stations further south, and but because I don't have the altitude, but because of your node, I can now connect to these stations without even having to reach for the radio tuner. So thank you for that. It's really, I think it's one of the most valuable gifts to the whole Bay Area, is this ability to cross-link these frequencies and across 2 bands. So thank you.
Yeah, glad it's of some use. It was a lot of work.
Yeah, I just like to second Hugo's comments. I'm Rick, and I'm not a member of your club, but I appreciate the invitation to join you all. And this is terrific, Jim. It's especially for people that are interested in using Packet for EmComm, and when we at the Red Cross are trying to continue that, and so it's wonderful to be able to have this opportunity to be able to connect to all these different stations now. So thanks much.
Yeah, that's great. Yeah, you're welcome.
Can one do it on a terminal program under Windows? We probably have to use Windows 7 to talk to the TNC directly, but is that a possibility?
Yeah. So when so everything I walk through is my node, right? Let's view that as infrastructure. But on my desktop here, I've got a TS2000, which I use as my VHF base. And I've got my Mac, and I run VMware, and I run Windows 10. And I've got a serial to USB cable from my Kenwood TS2000 that comes into my Mac. And I just boot up that VM instance of Windows 10. I run the program PuTTY. I have it connect over that serial port, over that COM port, right? And at 9600 and 81, and hit enter, and there I've got my command prompt to that TNC, and I can, if I tune to the right frequency, I can type 14505. I can type C space oak, and I'll connect to Hugo's node. So it can be as simple as that.
as a simple terminal
As-
user, I can dial into you or Hugo or anybody else.
Yeah.
And the radio is essentially our equivalent to our async telephone network, the
Mhm.
packet radio. Okay.
Apparently, the AX25 protocol, the A is amateur radio, I believe, and it's based on X25, which was used by telecommunications.
Yeah, the
systems.
Federal Reserve Bank used it for their backbone network back in the 80s, which I was my accountant. They didn't want to use IBM SNA because they want to be generic manufacturer independent. So they used X25 back then.
Yeah.
Roland or others, I use Windows, for most of my machines, and this laptop is what I use to connect to my node up here. But I'm using Cantronics units for my TNCs right now, and so anything that'll talk over serial can connect to those, right?
So we don't have to build that infrastructure other than to put a TNC to our radio.
Right. And so the Cantronics, has the bulletin board and all the AX25 and everything built into it. So it's much simpler to set up.
Mhm.
And the computer doesn't have to do any of that stuff. So, you can use any computer with a terminal program, right? Windows, Mac, Linux, whatever.
And just dial into somebody.
Yep.
Any other questions?
Jim, one last thing. So you have this infrastructure going on. I'm sorry, my video is not working. My camera is something wrong with it, so you cannot see me. But so you have this infrastructure going 24/7.
Yeah.
Good.
Yeah.
Thank you. Thank you. That's wonderful.
Yeah. For the photos, I had the backlighting on the radios, but I turned that off. I can't figure out how to turn the backlighting off on the Bridgecom radio. So.
And it's powered constantly from the battery.
Yeah. There's probably lots of ways of doing it. Again, this is, these are just familiar paths I took with my base station, so I just copied it. But that having this epic power gate and the rig runner, you've got a line from from your AC power supply into that, and then you have another line that can go to battery, and it can be lead acid or lithium. But the way it works is it'll charge. It'll do like a slow charge, to keep it live when you have AC power, and then when that power cuts, it's just a seamless transition to the battery power. So
UPS, yeah, the old-fashioned UPS type of thing.
Yeah, and it's different than like what I have for my network servers and stuff. I've got big, UPS that makes a audible click, right, when that thing kicks in and whatnot. But this seems like similar, but a slightly different technology for a 12-volt system.
Yeah, it's 12 volts, not 120.
Yeah.
UPS, right?
Do you get PG&E letters reminding you that you're not one of the least efficient houses around?
Oh yeah, I get them every month. This isn't my only project. Yeah.
Are
Very
you
cool.
30% or higher than the most efficient, or 50% higher?
I don't know. I have to go check, but I know there's a long outlier bar that's my house. So, but I again, even if you wanted to do an infrastructure node, what I showed in that photo, there's some stuff there like that network switch. That's not necessary. That network switch is not for the node itself. It will help the node, and it will help me to get it on the VLANs that I needed to get on for the Ampere network and for the mesh. But that's not necessary, right? You don't need 3 radios and 3 signal links. You don't even need like a display. I mean, you can run a node 24/7 that's a lot smaller. Like, remember what I had in the generation 1, right? It's a lot smaller. So even if you wanted to provide infrastructure, doesn't have to be at this scale, I guess.
Does it cost you anything if I stay logged on as a terminal 24 hours, 24/7?
I think there's a bunch of timers in the protocol, right? And so, and there's different protocols, AX and Netrom. So depending on what you're doing, right?
But as a minimalist, I can access packet with just a TNC modem to a radio.
Yes.
And there's no reason to stay connected unless you're actually doing something, right? And I know on the Cantronics, at least, I have to tell it how many connections to allow at any one time. And it's like, low single digits, like 1 to 3 or maybe 5, right? So you wouldn't want to sit connected to somebody's node for a long time unless you're actively using it for something, because it's, one command to reconnect when you need it again.
I'm just thinking of emergencies,
Right. Yeah, we should do some activities in the future, as we start to figure out our infrastructure stack, what it's going to be. We'll build some things out. We'll test some scenarios. We'll stress test it. There's still one goal that I have yet to achieve, and this requires Chris's participation, but everyone's welcome to join. When I first set this up, I told you I installed some games, and I installed a MUD, a multi-user dungeon, multi-user dimension. I created a little virtual world. I called it Ham World. So if you were to log in, if you were to connect to Montclair, the node, and you were to type MUD, you'll get a login screen to this virtual world. And all you have to do, it might be unclear at first, just type, connect and whatever your call sign is and make up a password. And you'll land into Ham World. And here's the I guess the lure. There's in there somewhere is the ORCA club meeting room at the fire station, and there's some tasty treats somewhere in there. So that's the challenge to all of you. Go see if you can find the virtual ORCA club meeting room in the Ham World off the node. And I would love to get a couple of us in there, because when you're in there, you can chat with each other, and you have the ability to interact with objects and whatnot. It's just a fun way of putting a virtual environment kind of construct around what would just be packet messages, text messages, chatting back and forth. So it would be fun to do that at some point to get everybody in there.
Jim, I think you're going to give the meta. Oops, sorry.
That's text-based gaming then.
Yes. Yeah.
You're going to give the metaverse a run for its money, I think.
Metaverse already exists on the node.
Awesome. Guys, it is almost 20 past 10. This has been amazing. Jim, thank you so much. Unless there are any other burning questions, and you all know you can always email the list or email Jim directly. But unless there are any other burning questions, let's take a 5-minute break and come back at 10:25 for the business meeting. Does that sound good?
Thank you, Jim.
Yes, indeed. Thank you so much.
Yeah.
Thank you.
That was a great presentation, Jim. Thank you.
Awesome. Glad you enjoyed it. Thanks, everyone.